Okay, so on this lesson, we're going to be looking at multiplying and dividing rational expressions. So before we can get to multiplying and dividing rational expressions, we first have to just simplify one rational expression. So a rational expression is a fraction, remember rational means fraction, in which a numerator and denominator are polynomials, so sum of monomials. Okay, so it says a rational expression is in simplest form when it has no common factors in the numerator and denominator. Okay, so remember we have to simplify if possible. So the domain of a rational function excludes any values that make the denominator 0. So remember we've been putting x can be all real numbers except, x cannot be whatever those numbers are that cause it to be 0. Okay, so excluded values are values for which the expression is undefined, which we just talked about, whatever causes your denominator to be 0. For rational expressions, exclude the values that make the denominator 0. It is easiest to identify these after you have factored. Okay, so the steps that we're going to be using to simplify one rational expression is first step, factor it. Second step, divide out any common factors and record any excluded values. So let's look at our first example. We have to factor numerator, denominator. So notice the numerator has a 3 in common, GCF. And that leaves me with x squared minus 1. We have to factor completely. So looking inside, notice I still have a squared, which means I need to see if I have difference of squares since it's a binomial. I can factor again. That would be x plus 1, x minus 1. The denominator, notice it's a trinomial that does not have a GCF, so I need to use sum and product. Sum is 2, product is negative 3. So I want to find two numbers that add to 2 and multiply to negative 3. So that would be negative 1 and 3. So I would have x minus 1, x plus 3 in the denominator. Okay, so once I have factored the numerator denominator completely, I look for common factors. Notice that I can cancel out the x minus 1s. Remember, they have to look exactly the same to cancel them. So on top, I'm left with 3 and x plus 1, and then on bottom, I'm left with x plus 3. Now, once you have got your answer, which this is my answer, once I've got it, I need to look for any, like we said at the top, any excluded values. So whatever value would cause this to be 0. So I know x cannot equal negative 3 because that would cause my denominator to be 0. Now I also have to look back up at the top before I canceled. The other x value that it could not equal would be 1, because if I plug in a 1 up here to this original, that would also cause it to be 0. So make sure you're including both x values before you cancel. That would make it undefined. So there would be my answer. Okay, looking at the next one. First step, factor. So notice this is a trinomial that does not have a GCF. So I want to use sum and product. Sum is the middle number, so 5. Product is what you get when you multiply the outsides, which would be 4. So we're trying to find two numbers that add to 5 and multiply to 4. So that would be 1 and 4. Now, I'm not finished here because x times x does not give me 2x squared. So remember, whatever this number is in front, if it's not a 1, I have to divide it and use the swing method. So I reduce if possible. Notice I cannot reduce the 1/2, so I'm going to swing the 2 in front, which would make it 2x plus 1. I can simplify the next one. 4 divided by 2 is 2. So there's my two factors. Looking at my denominator, notice that I have a 2x plus 1 that I can't factor, so I'm just rewriting it. Now notice these cancel out, which just leaves me with x plus 2. Now I need to also remember the excluded value. So looking back, I now know that I don't have a fraction, but I started with a fraction. So looking at your denominator, if you set that equal to 0, you would subtract 1, divide by 2, and so negative 1/2 would cause this denominator to be 0. So make sure you include that in your final answer. So I know that x cannot equal negative 1/2 because it would cause that original denominator to be 0. All right, so let's look at part C. Okay, so notice here that the top is just a monomial. It just has one term. So we could just leave it like that, or we could also write it as 4 times x if you want to write 2 x's there. Your choice. Okay, so you could leave it as 4x squared if you wanted. Okay, so on the bottom, GCF, factor it. They notice they have a 2x in common. So when I take out a 2x, I'm left with x plus 5. I can't factor it anymore, so I need to look and see if I can cancel anything. So notice that I can cancel an x with another x. So that leaves me with a 4 on top and then a 2 on bottom. So I can also simplify that as well. And 4 divided by 2 is just 2 over 1. So I would have a 2 and then this part, x on top. This is just a 1 now, 2 over 1. So I have an x plus 5 in the denominator. So there's my simplified answer, but make sure you include your excluded values. So looking back after we factor it, 2x equals 0 would be x equals 0, and x plus 5 equals 0 would be x equals negative 5. So my excluded values would be x cannot equal 0 or negative 5 because it would cause my original denominator to be 0. All right, looking at D. Notice here we have 6 minus x on the top. It's a binomial. Notice they don't have anything in common. And it doesn't have a squared or a cube, so I'm just going to rewrite it. It can't be factored. Now looking at this one, notice I have an x squared minus 36. They don't have a GCF, but they do have 2 terms, so we check for difference of squares. Notice 36 is a perfect square, so is x squared. That simplifies to x plus 6 and x minus 6. Now notice the top here is very similar. So if I rewrite this, that's the same thing as negative x plus 6. But I don't have a negative x plus 6. So what I could do on the top is I could take a negative out, which would leave me with x minus 6. That means the same thing. So if they look very similar, you need to check and see if you can kind of get it in the same form so that way you can cancel it out. So notice now I'm able to cancel these, which would leave me with a negative 1 on top and then an x plus 6 in the bottom. Now don't forget x cannot equal negative 6 here and positive 6 on the other one that's already been canceled. So don't forget your excluded values there. Okay, so this is simplifying one rational expression. So you're having to factor everything if possible, and then you're just simplifying by marking things out that we have in common on top and bottom. So let's flip over. Now we're going to get into the multiplying. So to multiply, you're first going to factor the numerators, denominators like we were just doing. Then we're going to multiply the numerators and denominators, and it says write the factors next to one another, but do not redistribute them. So make sure you're not redistributing them. You're going to divide out the common factors. So if they have any common factors, you're welcome to mark those out, or you need to mark them out. And then you're going to write the simplified expression, including any excluded values. All right, so first step is to factor everything. So first, we have a sum. It's a trinomial, sum of 1, product of negative 30. So that would be a positive 6 and negative 5. If you can't do it in your head, list them out in order. Looking at my denominator, notice they have a GCF of 9. So make sure you include the 9. When you take that out, you're left with x minus 5. Bring down your multiplication sign. Factor these as well. So GCF of these two would be 3x. That leaves you with x minus 5. And then the denominator, it's a trinomial, so sum is 9, product is 18. So that would be 6 and 3. All right, so right when you get to this point, you're going to start looking to see if anything can cancel. To cancel terms, they have to look exactly the same if they're a binomial or a trinomial. So we need to look, we can cancel across from each other, like diagonal from each other. I'm sorry, not straight across, but diagonally from each other. And you can also cancel on top and bottom. So notice here, these x minus 5s will cancel out. And then notice I have an x plus 6 here and an x plus 6 here. And then notice, since this is one term here, this is one term, I can reduce the 3 and the 9, so that'll be a 3 there. So I have on top x, because notice I still have an x here. So an x times an x minus 5. And then in bottom, I have a 3, and then I have an x plus 3. Now, looking at your denominators, you have two denominators this time. So make sure you're looking at your denominators. This one would cause it to be 5. This one would be negative 6. And this one would be negative 3. So make sure you're looking at those values to see what would cause it to be undefined, which is a 0 in the denominator. So there's my simplified rational expression. Okay, let's try another one. Notice this one, we just have a 6x on top, so we can just leave it as 6x. The GCF of the bottom two, we have a 2x, so that leaves me with x minus 8. And then I'm looking to see if I can factor this trinomial. Notice it's not in fraction form, but I can put over 1. So sum is negative 11, product is 24. So that would be negative 8 and negative 3. And then we look to see if anything will cancel. So notice x minus 8 cancel diagonally. Notice this x cancels with this one. And then we can simplify this and make it a 3. So you're multiplying the top times the top. So I have a 3, and then I also have an x minus 3 in the top. Bottom times bottom. Notice there is nothing besides a 1. So I actually don't even need a fraction there. So looking at my denominators, that would be a 0. Because 2 times 0 would cause that to be 0. And then this one would be positive 8. So x cannot be 0 or 8. So lots of factoring. All right, number 3. Mia multiplied the rational expressions together and determined the simplified expression was 5/3, and x cannot be negative 3 or 0. You're going to check Mia's work. If she is correct, explain how she multiplied the expressions. If she's incorrect, explain what misconception she may have had resulted in her answer, and then correct her. So let's just go ahead and start working it out. So I'm going to factor. So I can't factor 5x squared, but if you want, you can do 5 times x if you would like to do that. Then I have, bottom here, I have a GCF of a 3x, which leaves you with x plus 3. And then trinomial, sum is 6, product is 9, so that would be x plus 3, x plus 3. And then the denominator of x. So I need to start canceling. Notice I have an x here, an x underneath it. I also have an x here and an x diagonally. And then x plus 3, x plus 3. So multiplying straight across, I have a 5. Also, I have an x plus 3. And then I have a 3 in the bottom. So notice we did not get 5/3. We got 5 times x plus 3 over 3. Also, looking at your excluded values, x cannot be a 0 there, or a -3, or a 0. So we only have to write the 0 once. Okay, so what she probably did here, notice there was an x plus 3 and an x plus 3 here. She marked out both of the x plus 3's on top, but we can't do that. Only one cancels out with 1. If there was another one on the bottom, then we could. So you're welcome to write that out on your notes. So let's go ahead and move to the next page. Now we're going to be dividing rational expressions. It's very similar to the multiplying, except when you divide with fractions, you're going to have to keep, change, flip. So keep the first fraction the same, change your division to multiplication, and flip the second fraction. So you're still going to be factoring everything, and then you're going to keep, change, flip, and then you'll see if anything simplifies out. So I'm going to go ahead and start with factoring. So trinomial, sum is 4, product is 3. So that would be 3 and 1. Hopefully you're getting faster at factoring. If not, keep practicing. So trinomial, sum is 2, product is -8, so that would be -2 and 4. Now, since this is division, I have to keep this first one the same. I have to change my division to multiplication, and then I have to flip this fraction, which means this is now my numerator. So sum is -3, product is 2, so that would be -2 and -1. This is now my denominator. Sum is 7, product is 12, so that would be 4 and 3. All right, so I need to look and see if I can simplify by marking and canceling terms out. So notice I have an x plus 3, an x plus 3. Notice x minus 2, x minus 2. And that's it. So multiplying your tops together, but not really multiplying them, just putting them together, I would have an x plus 1, an x minus 1, and then looking in your denominators, I have 2x plus 4. So you can either write it twice, or you could put x plus 4 squared if you wanted to write it like that. So either way right there, I'll accept. Now looking at your denominators, that would be, x cannot be 2. That would be -4. -4, we don't have to write it twice, and then -3. Okay, so there is our answer. So very similar to multiplying, except when you divide, you have to keep, change, flip. So don't forget to do that. So always pay attention to your sign, excuse me, at the beginning, so you know if you need to keep, change, flip or not. So I'm keeping my first one the same. I'm changing this one to multiplication, and then I'm going to flip this. It's over 1 right now, so it will become 1 over that. So factoring, first step, notice the top, they have a 3 in common, so you're left with x plus 5. Denominator, trinomial, sum is 9, product is 14. So that would be 7 and 2. I'm changing, that's the whole purpose of me writing C. I need to change that to multiplication. The F means I need to flip it. So I now have a 1 on top. My sum of the denominator is now 12. Product is 35. So what's that? 5 and 7. So x plus 5, x plus 7. Okay, so we simplify if possible. Notice there's an x plus 3, or x plus 5, x plus 5. And that's it. So notice multiplying the tops, I have a 3 and a 1, so that gives me a 3. And then I have notice there's 2x plus 7, so I can write it twice, or I can put squared and then x plus 2. So you can either write it twice, or you could put x plus 7 squared since there's 2 of them. So looking at your denominators, that would be negative 7, negative 2, negative 5, and then you would have negative 7 again. So there's our excluded values. Okay, so multiplication, division, very similar, except on the division, you're having to keep, change, flip. Don't forget to do that. So you're having to factor a lot. So if you're struggling with factoring, make sure you're coming in to get help on that. Let me know if you have any questions.